Forces at an angle. A girl pulls on a 40-kilogram dog's leash with a force of 80 newtons. The dog slides backwards at a constant velocity. The leash is at a 20-degree angle with the horizontal. To solve problems with forces at an angle, we use the same approach that we did before. Start with drawing a force diagram, and then complete the force table. Being on Earth, the dog is going to have a force of gravity acting on it down. The tension from the leash acts up and to the left at an angle of 20 degrees. With the dog being on the ground, there's probably a normal force up. I say probably because the dog's moving at a constant velocity, meaning the forces are balanced. The force of tension already acts up, so there's a chance that that could balance out the force of gravity and there not actually be any normal force. But we'll see that when we get to the force table. This problem says nothing about friction. However, for the forces to be balanced, I already have a force to the left, meaning I need to have a force to the right in order for the forces to be balanced. That's going to be the force of friction. I'll then add each of these forces into my force table. Since this is going at a constant velocity, the net forces, or the total forces, are going to be 0. Let's go through what I know for each force. I'm given the mass of the dog, 40 kilograms, so I can find its weight, or the force of gravity. Since that acts straight down, there's going to be 0 x component, and the y component is going to be 40 times 9.8 m times g, which equals 392. Since that force acts down, that's in the negative direction, it needs to be negative 392. The tension force is where things get tricky. Up to this point, we've only had forces act in one direction, so they only had one component, either x or y. Since the tension force acts to the left and up, we're going to need to break it up into components. This is exactly what we did in the previous videos. You may need to refer to them on how to break a vector up into its components. This 80 Newton force acts at an angle of 20 degrees. I skipped over the math on actually breaking it up into components. If you need a refresher on this, again, see the videos either breaking vectors into components by hand or breaking vectors into components using trig. After breaking this 80 Newton force up into its components, it has an x component to the left, so it's negative, and it's 75.2 newtons. In the y direction, it's up, so that's positive 27.4 newtons. I know if there is a normal force, it's going to act straight up, so its x component is 0. I don't yet know what the y component is. It's easy to just say it's going to balance out the force of gravity, but in this case, it's not, because the force of tension has a y component. So let's come back to that. We'll move on to the force of friction. The force of friction is going to oppose the motion. If the dog is moving to the left, the force of friction would be to the right, and its y component will be 0. Now in the x direction, I only have one box left. In order for all of these forces to be balanced, they need to add to be 0, which means the friction force needs to be positive 75.2 newtons. Similarly, in the y direction, all of those forces need to add to be 0. So, negative 392 plus 27.4 plus whatever the normal force is has to equal 0. Negative 364.6 plus the normal force equals 0. Then if I add 364.6 to both sides, I get that the normal force is positive 364.6 newtons. And you see here that the normal force is actually not the same as the force of gravity. Now that I've found all the forces in the force table, I'm done with this problem.